Alright, so let's, our objective today is to understand and use the midpoint formula. Again, not to be confused with the midpoint theorem. They talk about two completely different things. So just a recap, midpoint theorem. Chapter 2 said, if M is a midpoint of segment AB, then the length of AM is equal to 1/2 the length of AB, and MB is equal to 1/2 the length of AB. So, in a nutshell, if M is the midpoint of segment AB, so here's AB, here's M, then that piece AM is equal to 1/2 the length of the whole thing, and that length BM is equal to 1/2 the length of the whole segment. Now this is the midpoint theorem. That's not what we're talking about. Okay? So the midpoint formula is theorem 13.5. Oops, sorry. With a name, strangely enough, the midpoint formula. And it states the midpoint of a segment that joins points x sub 1, y sub 1, and x sub 2, y sub 2 is the point x sub 1 plus x sub 2 divided by 2, y sub 1 plus y sub 2 divided by 2. The midpoint formula tells you where the midpoint is located. So it's directions to find where the midpoint is. I add my two x values, so the endpoints of my segment, and I cut that distance in half. That's the location. Now, some of you may say, well, aren't we supposed to subtract them and cut in half? If you subtracted your x's and cut in half, that tells you how far from an endpoint you need to travel to find the midpoint. This tells you, plain and simple, the location of the midpoint. So if you were remembering doing subtraction, it's telling you the distance. And I think we did that earlier in the chapter, where we were trying to figure out how far from this endpoint would the midpoint be. And we could use subtraction to do that. Okay? All right, so let's do a couple practice problems on this. Let's see. Find the midpoint of the segment that joins negative 11, 3 and 8, negative 7. So all we do is take those 2 points and we plug them into the midpoint formula. So the midpoint is going to be located negative 8 or negative 11 plus 8 divided by 2, 3 plus negative 7 divided by 2. Keep doing some math. We get negative 3 over 2, bless you, and we have negative 4 over 2. I can leave the negative 3 halves, but I do need to simplify negative 4 over 2 down, to negative 2. And there's your answer. That is the location of the midpoint for those, between those 2 points, okay? All right, now we're going to get a little bit more complicated. This one says, given A is at 2, 1, and B, which is at 8, 5, show that point P, which is at 3, 6, is on the perpendicular bisector of segment AB. Okay, so this is how we take a concept and geometrize it. And I do mean like traumatize with geometry, okay? Because now all of a sudden they go from here's 2 points, plug in the numbers, figure out where it's located, good, I'm done, to, okay, now we're going to throw vocabulary at you and you have to understand what it means. So what do we know is true about a perpendicular bisector? Oh, that was supposed to be a different color. Hold on. Okay, one thing. Isabel.
If a line that intersects another line in its midpoint,
Okay. Hold. Okay. Stop. You gave me too much. That was more than one thing. So it intersects a given line at its midpoint, which comes in handy that we've just learned how to figure out where a midpoint is. So this is how they're applying this new idea. And then we'll let somebody else repeat what she said was the second piece about a perpendicular bisector. This, what Isabel we wrote down, deals with the bisector part. Okay? So the other part, Drake P? Yeah. And then we have it's perpendicular to the given line. So what do we know about perpendicular lines? So we know that the slopes are what? Opposite reciprocals. So from that vocab word, we know we need 2 pieces of information. We need to know where the midpoint is on our line, and we need to know that we need to know slope. Okay, so let's start with midpoint. So midpoint is going to be, let's see, 2 plus 8 over 2, 1 plus 5 over 2, which gives me 10 over 2, and 6 over 2, for a grand total of 5, 3. So that's the midpoint of this line that contains A and B. So we'll call him M for midpoint. Okay? And then we want to figure out the slope of AB. So that's a small m. And to do slope, we're going to take the y's and subtract them, and the x's and subtract them. So 1 is over 2, 5 is over 8. So I get negative 4 over negative 6, which simplifies down to positive 2/3. Okay, now, P is on this perpendicular bisector. That means it has to pass through. What does it have to pass through? Which is called the midpoint. It has to pass through the midpoint. So now what I want to do is to figure out the slope of this line we think is a perpendicular bisector, which would be the line PM. So P is at 3, 6, M is at 5, 3. So, oops, sorry, I don't need that. So the difference, let's see, we've got y over x, there's your m, 6 over 3, there's your p, connect and subtract. And let's see, I get negative 3 over 2. So to test to see if these lines are perpendicular is I can take those two slopes and multiply them, and if I get the number negative 1, then I've just proved that they are perpendicular. Yes! Perpendicular! Okay. So what I've just proved is that segment AB is perpendicular to segment PM. Okay? So again, you have to use your vocabulary. What do I know about that particular object? How does it relate back to what we're talking about? Oh, midpoint. I need to know where it is because that line has to pass through it. Oh, perpendicular. Oh, slopes. What do I know about them? Oh, perpendicular slopes are opposite reciprocals or their product equals negative 1. And that's the geometry traumatic event in geometry. That's how it works. We don't, because actually the first question was more like what you would have done in 7th grade or 8th grade algebra class. Probably even in a pre-algebra class, you could have done something like that. So, okay, that's what you guys get to work with tonight. And I'm the evil queen who didn't give you a whole lot of, didn't give you all odds this time on your homework. So, you have to think hard.